Alrighty, we're getting ready to a point, or getting to a point in our Android programming that we probably should just take a little minute or two and discuss the notion of object-oriented programming in terms of constructs, so that we're communicating when I start relating other characteristics about about Android programming, specifically having to do with applying styles and themes to an activity, and of course being able to write Java code for the Android. These, the whole world of object-oriented programming is absolutely responsible for even making it possible to create an Android device. So it's important to understand these constructs and where they're coming from. So in order to do that, what I decided to do is I'll use this thing right here. When I was growing up, we called these things cootie catchers. All right, I'll use that as kind of my example for relating these concepts, and hopefully it will make sense to you. So what are we going to talk about? We're going to talk about what a class is, what an object is. We're going to talk about encapsulation, inheritance, polymorphism, what an abstract class is, or abstraction, if you will, and what composition is. So let's begin with what is a class. A class, for most people, when you go through programming, depending on who you talk to or what class you were in, some people will describe a class as a cookie cutter. Okay? The problem with that description is, certainly in my case when I was learning about object-oriented programming, is I just kind of assumed that the class just stood out there. It was a body of code that really didn't do anything other than was used as maybe a template for creating what is known as an object. An object is a thing. It is a model of a thing inside of our program, which we'll talk about a little bit later on, a little more detail. In truth, a class is a lot more than a cookie cutter. A class is a cookie machine. It is code that is running. It is code that is doing work for you. Okay? It is capable of producing an object, but in fact it doesn't have to produce an object. It can do things without ever producing an object. Okay? It can have its own variables that are unique to the class, and we call those static variables, and basically that means that any object that's created from the class can see those variables. Some people say, well, what good is a static variable in the class? Well, one good example is you can actually store, or you can have a variable that keeps track of the number of objects that was created from that class. Okay? It can have its own methods, all right, and they would be called static methods, and sometimes they actually include a main. They include a main in circumstances where the class does not necessarily need to be used to create an object. Okay? New programmers tend to focus more on a class as a recipe for creating objects than they do about the notion that a class is in fact running. It is doing stuff. It is doing work. Okay, so it is alive as far as we programmers are concerned. Okay, so let's say we're going to create a monster class, and our monster class is going to be the little cootie catcher, which we'll now call our monster. Okay. The very first thing that we want to do is we want to create an object that's going to be a monster. It could be a North Pole monster. It could be an American monster. It could be a Hispanic monster. It could be a South American monster, whatever we want. Okay? In other words, it's going to have certain characteristics and attributes to it. So when we say that we're going to create an object from a class, we are saying that we are instantiating that object. We're creating an instance of the monster class. It's a term that has kind of been forgotten in the English language these days. I remember when I was younger, we always used the word instance, but not anymore. It seems to be a little bit confusing to people. An instance is the existing of a single thing, a single entity, if you will. Okay? So here we have our little object that we're going to create, and it's going to contain characteristics or attributes. Okay, attributes are things that come to life at instantiation. That is the moment we create an instance of the object. Most of these attributes are hidden because we want to encapsulate them. We want to make it so that other people can't inadvertently gain access to them and make changes to them. Helps us with security. Some of them are visible. We might want to just go ahead and gain access directly to them. Not a lot though. It's not that often, and it's not good code practice to take your attributes and make them completely visible. It's better to hide them and then write a little method or a function, if you will, whatever you want to call it, to gain access to those hidden attributes. Okay. For example, we would have a color attribute. Okay, and here we have that it is private, which means it's going to be hidden. It's going to be in this, when we instantiate the object, nobody's going to be able to see it at all unless we do something. All right, so we have one that's called private. It's going to be a string, and it's going to be color. We have another one, a little minus sign there. It is the number of teeth. It is private. It is an integer, and it gives us the number of teeth. We have another attribute that is going to be private, and it's going to give us the kind of teeth, and then we finally have another attribute that is a growl sound, if you will. What kind of sound does our critter make? Okay, so we can also have methods that will allow us to be able to get to these attributes, or to be able to do certain jobs for us. For example, methods can be hidden. They can be visible as can attributes. All right, we can have a method that says smile. So private void smile. There it is. It looks like a function. It's a method, and in there we would do the code. So what would the code be? Well, it could be just nothing more than a message to the user. If we're just writing a program that does console input and output, we can say monster just smiled, exposing happy pearly white teeth. Whatever we want to call it. We can also create what's called a getter. A getter simply allows us access to be able to get a hold of information that's in an attribute. Okay, so here we have public. Got to make sure that it's public, because in case the smile is private, can't see it. The monster, this here critter. Let's see, how can I put this? Since I made the private smile, something within this object is going to have to call this method, okay, or use this method, or message this method, whatever terminology you want to use. All right. In the case of getting the number of teeth, it's going to be a public attribute, or I'm sorry, a public method, and so we go public int. We're saying what type of data we're going to be returning. Get the number of teeth, and then it's going to return the number of teeth, right? And if we want to set the number of teeth, we would say set the number of teeth, public void, set the number of teeth. We're not returning anything. You could, if you wanted to, you could return maybe a success boolean or whatever. Here we're going to, it's expecting an integer, which is the number of teeth. And then you say this dot number of teeth, because numTeeth was an attribute, is equal to nTeeth. So nTeeth goes into this particular object. That's what this means. All right. Hopefully you're getting that because you've taken Java. Why do we do this? Why do we create getters and setters? Well, what if our monster can't have more than 32 feet? We can put error trapping right here that says if nTeeth is greater than 32, then don't set it, right? And maybe return an error, in which case void would now be some data type. All right. This whole notion of course, hiding the attributes is called encapsulation. This whole notion of hiding methods is also called encapsulation. So let's say we have ourselves a monster class. I've given you, this is the class itself, okay, this is the class. In other words, it's the instructions to be able to construct our monster object. So classes are going to have some kind of code in there that is a constructor method, and the method is usually the same name as the class, okay? And inside the method, the constructor is all the code that we need to be able to make our monster class come to life. And for some classes, when you do instantiate an object from those classes, you may not need to construct anything. Okay, and if you don't bother to define a constructor, then what will happen is the superclass, to the class that we're currently working with, will invoke its constructor automatically. Okay, so let's go ahead and go to the next slide.